section, we are talking about rational equations and inequalities. Today we're only going to get to the equation piece. So we've been graphing these rational functions. Now we're going to solve equations with them. So here is our first example. 2x minus 3 over 2 plus 2x over x minus 1 equals x. What I want you to do on these, very first thing, is look to see what answers are possible. We've talked about if you have a fraction, what can't happen? Okay. Does 2 ever equal 0? No, so I don't have to worry about that. Does x, what would make x minus 1 0? So I'm just going to make myself a note that x cannot equal 1. I'm just going to kind of set that off to the side so that when I get to my final answer, I check it and make sure it's okay. Now, there are different approaches we could take for solving this, but in general, I have found that you guys like to avoid fractions if you can. Is that still accurate? Okay. So if I wanted to get rid of this 2, what would I have to do? Multiply by 2. All right, I'm rewriting this just so I have a little more space. Okay, so to get rid of the first denominator, we would have to multiply by 2. But can I take just one thing times 2? No, so you have to do it to every single term on both sides of the equation. So what that did is it canceled here. Do I have any other fractions to worry about? I have this one. What would I have to multiply by to cancel it? X. Just the same thing. X minus 1 would get it. So if something's on the bottom, you just multiply by it to cancel. But you can't do just one piece. You have to take everything times that. So just to show you what we have. The first term, we had that 2x minus 3 that was on top. The 2's canceled, so we have times an x minus 1. Second term, we had a 2x, and we're left with times 2. Over here, x times 2 is 2x times the x minus 1. So at this point, all of my fractions are gone. So then it's more like equations we've solved in the past. What am I going to have to do first? Distribute, multiply it all out. So this first one we have to FOIL. So we get 2x squared minus 2x and minus 3x would make a minus 5x. Negative 3 times negative 1 is positive 1. 2x times 2 is 4x. Over here we get 2x squared minus 2x.
Would the negative 3 and the negative 1 make a positive 3?
Yes, it would. Thank you. Okay. What happens if I subtract this 2x squared over? Those x squareds cancel. Negative 5 and positive 4 would be a negative 1x plus 3 equals a negative 2x. If I add my x over, I get 3 equals a negative x divided by negative 1, and x is negative 3. Now, at the end of this, you do have to kind of check your answer, so you have some options for that. You could plug it into the original equation, and it should work. Always a good idea to do that. At the very least, confirm it with this. We already said that x can't be 1, so it is negative 3 an okay answer? Yes. So that is my final answer. Any questions there? Let's just do some more. What can x not be on this problem?
5.
Positive 5. Okay. Again, you don't have to rewrite it, I'm just doing that because I need more space. So, to cancel my first fraction, what do we have to multiply by?
X minus 5.
And you have to take everything times that. When I do that, those x minus 5's cancel, and so do these. So do we need to multiply by anything else? No, we've got rid of all the fractions. So I'm left with just an x on this first one. 5 times x minus 5 equals 5. Alright. Distribute. So if I add like terms, we have 6x. If I add over my 25 equals 30. Divide by 6 and x is 5. Okay, we said x cannot be 5. So if you get 5 for an answer, but x can't be 5, what do you think our answer is?
Solution.
If you tried to plug that into the original to check, you would end up with 5 divided by 0, which is undefined, so it doesn't work. Questions there? Let's say I gave you this one. If we're trying to decide what x cannot be, what would make a 3x squared equal 0? 0. What would make a 2x 0? 0. What would make 6 0? Nothing. So the only thing that x can't be on this problem is 0. Alright, to cancel this first denominator, what would we have to multiply by? 3x squared. Okay, so those cancel. In the second fraction, what would drop out there? One of those x's would cancel. So for the second fraction, what do we still have to multiply by? The 2. So then that part cancels. Do I need to multiply by a 6?
No.
We already kind of have, haven't we? 3 times 2 is 6, so wouldn't that cancel this 6 already? Now, if you went ahead and multiplied everything by 6, it's not going to give you the wrong answer. You'll just have more reducing to do later on. So we are left with 7 times 2 9 times the 3x and 13 times x squared. Does everybody see how I got that one?
Is the 9 times 3x squared in there?
We canceled one of those x's out. 14 plus 27x plus 13x squared. If it's a quadratic, we have to set it equal to 0. So subtract over the 27x and the 14. Yuck. There's a do box method here. Okay, if you multiply those together, they multiply to 182. And add to a negative 27. What's gonna be? You guys figure it out. Can I make a change to this problem? Because this isn't gonna work and I really intended this problem to work nicely. Can I add a negative on my 13 right here in the original problem? That would make it a negative 13x squared. So here, if I bring my 13x squared over, now it's 13x squared plus 27x plus 14 equals 0. So now it's going to work. Sorry about that. So this is a positive 14, so they have to multiply to positive 182 and add to positive 27. 13 and 14. Okay, so we can factor, we can take out 13x, 14x, and 1. So we have to set each of those equal to 0. And x plus 1 equals 0. We get -1. Make sure, what was the only thing x could not be?
0.
So both of these answers work. Any questions there? And I want to look at this problem. All right. So if my denominator is x minus 2, what can x not equal? Okay. If my denominator is x, what can x not equal?
2.
For this last one, I recommend, if at all possible, factor your denominator, because we don't want to multiply by more stuff than we have to. How would I factor that? What does that break into? Yeah, you can take out an x, and then you're left with x minus 2. So you can see to make that 0, you would need either a 0 or a 2, and we've already listed both of those. Alright, now we have to cancel all of our denominators. So the first one, multiply by what's on the bottom, so I'd multiply by x minus 2 to to everything. This would cancel. The x does not cancel. It has to be exactly the same. So this is an x minus 2. It wouldn't cancel that x. But it would cancel the x minus 2 over here. What do I still have to multiply by? An x. So those drop. And these drop. So I'm left with, in the first one, 3x plus 2 times x. Second fraction I have 1 times the x minus 2. Last one we have negative 2 times nothing. We start multiplying out, we get 3x squared plus 2x plus x minus 2 equals negative 2. Combine like terms. If I add over this 2, what happens? Those cancel. How would I solve this? Factor out 3x. Use this with x plus 1. So what makes 3x equal 0? 0. What makes x plus 1 0? Negative 1. What do I need to do at this point? I have to check them, see if they work. Can x be both of those numbers? No, it cannot be the 0, so my only answer is negative 1. So we've seen we might just get one answer on these, we might get two answers, or we could have a no solution when we're solving these. So far so good. We want a more challenging one? Let's do, I'm probably only going to do one or two more. Let's do this. Alright. Where am I going to begin on this one? Factoring everything. Okay. So, what multiplies to 6 and adds to negative 5? Good. X squared minus 4 breaks into x plus 2, x minus 2. Alright, this one, I kind of gave you an ugly one. What are you going to have to do to all of this first? Take out a 2. So that 2 stays, and then we can do box method with what's left. What would multiply to negative 12 and add to negative 1? Oh, yes I would. My goodness. I should just quit today. I'm not doing it. That's 6, because I took out the 2. So multiply negative 6 and add to negative 1. Okay. So let's write down what x cannot equal. What would make x minus 2 0? 2. What about x minus 3? 3. Okay, looking at all of our fractions. This one, x plus 2, so x can't be. X minus 2 would just give us a 2, which is already on the list. Does this fraction give us anything new? No. So there are 3 things that x can't be this time. Okay. For the first one, what would I have to multiply by? Right, everything that's on the bottom. We'll take it to all of these. So the 2, x minus 2, and x minus 3 cancels. The middle fraction, the x minus 2 drops, and the last one, the x minus 3 drops. So a lot of stuff canceled out there. Looking at the second fraction, what do I need to multiply by? We'll take that to all of those. So those drop. And these drop. Is there anything still on the denominator? A 2. So now I take everything times a 2. Okay. So in the first one, 2x times 2 would be a 4x, and we still have to multiply that with an x plus 2. Second fraction, 1 times 2 is a 2, and we have to take that times the x minus 3. And the last, we're left with x plus 3 times an x minus 2. Now what? So we get 4x squared plus 8x plus 2x minus 6 equals x squared plus x minus 6. Okay, we need to set this equal to 0. So if I subtract over my x squared, that's a 3x squared. Add these two and you get a 10x. And I need to subtract over that x, so we would have a 9x. And if I add my 6, those cancel, so equals 0. We can do what now?
X.
3x, and that leaves us with x plus 3. Set each of those to 0, and what do we get? 0 and negative 3. Are both answers okay to have?
Yes.
We said it couldn't be positive 3, but a negative 3 is fine. That one was a little uglier. Any questions there? I'm going to put one last problem up here. I want you guys to try it. Just take a few minutes and see how far you get, and then we'll start talking about it. So factoring at the beginning just helps make your problem prettier later. So if you take out that x, you're left with x minus 7. X squared minus 49, difference is squares, x plus 7, x minus 7. So x cannot equal for the first one. This x would just give us a 0. X minus 7, so x can't be 7. X plus 7, negative 7. That x minus 7 gave us a 7, so we're good. So those are the 3 things x can't be. So for the first fraction, you have to multiply by everything that's on the bottom. So an x and then x minus 7. And you take that times everything. So this cancels entirely. And this one, the x minus 7 drops out. We still have an x plus 7 on the bottom, so now we take everything times x plus 7. So then those drop out, and all of the fractions are gone. So we are left with 4 times the x plus 7 minus 1 times the x equals, what's 0 times anything? So I get 3x equals negative 28, and x is negative 28 over 3, which wasn't one of the things x can't be, so we're done. Like I said, if you didn't factor your denominators, you would have ended up with a nasty quadratic to solve, but it would get you to the same solutions in the end. Any questions there? We have about 15 minutes left. There is a Math Excel assignment. We can get started on that. Please ask for help when you need it.